Hey guys, so today we're going to look at equations and we're also looking at number patterns. So I have an example of each to kind of walk you through how it looks. This is the equations one. So first thing you're going to do is read the problem, underline important information as usual. Mr. Gonzalez is putting a fence around the perimeter, the math word, so I'm going to underline it, of a playground. The perimeter, there's that word again. The perimeter of the playground is 144 feet. Each section each section of the fence is 4 feet long and costs $12. Okay. Which equation can Mr. Gonzalez use to find B, which is the cost of the sections of fence, sections is in plural, more than one, that he needs for the playground? So anytime you have a word problem has bulleted information, majority of the time those bullets are kind of important, so make sure you pay attention to those. So I'm going to draw a picture because it just helps visualize it of a playground. There's my playground. There's my slide. There's my swing, but none of that matters. Okay, but the the perimeter talks about the area around the outside of the playground. So that black line that goes around this outside of the playground, that is the border of the playground. That is the perimeter. Remember, perimeter does not include the space on the inside. So whatever equipment you have doesn't matter. The perimeter is the outside of the playground. So we know, according to bullet number one, that the perimeter of the playground is 144 feet. So I'm going to write that down. Bullet number two tells us each section of the fence is 4 feet long and costs $12. Keeping in mind, a fence does not come in one huge piece. They're in sections. So for example, this spot to this spot, that is one section. That would be about 4 feet, and that one piece would cost $12. Question is, how many sections are there so we know how to find the cost? So step one, you're going to take your total, 144, and we wanted to divide that by 4. The reason why is if you take your total and we divide it up by 4 feet, we're splitting that total into 4 feet parts, and we want to see how many parts we get, or in this case, how many sections we get. After you divide that, and that's first, by the way, so I'm going to put parentheses because it has to be done first. And after that, you're going to take however many sections you have, and you're going to multiply that by 12. Because when you take your units times the amount they are cost each, you're going to get your total cost, which is B, what we're trying to find. So in these kind of problems, you're trying to see which equation would actually help you solve the problem. Knowing what each number represents helps. I know 144 is the total perimeter. I know 4 is one section apiece, or a fence. I know 12 is how much one section costs. Knowing that, you can use reasonableness if these over here make sense. Like F, for example, says to take, go parentheses first, take your cost and you divide it by how long one section is. That doesn't sound reasonable to me, so it doesn't make sense. So if you go through all your answer choices and you worked it out prior like we just did, you would see that J is the only answer that makes sense. It matches what we just did. Okay? That's an example of an equation type problem. Now, number patterns is the whole rules thing. So this one says which table the value does not. Ooh, look at that where it's all capitalized. I'm going to square it because that's important. Which table the values does not represent y equals x plus 4? Just to give you a quick reminder of what a table and the rules, how it works. You have your x, you have your y. X can be known as an input, y is your output. What that means is whatever you put into x, a rule applies and gives you y. Some of you learned about a robot. You put in a number, the robot applies the rule, and it spits a different number back out after the rule was applied. I use the example of a Coke machine. You want to buy a Coke, say for example, $1. You put in a $5 bill, so you put in 5. The machine does the process. It keeps $1 and spits you back $4 and hopefully a Coke. But anyways, you inputted 5 and it gave you the output of $4 and change. So same rule thing applies. In this case, y equals x plus 4.5 is the rule. So if x was 1, for example, you would do 1 and then you would do plus 4.5. It's hard to write with this thing. 1 plus 4.5 is 5.5. So x would be 1, y would be 5.5. That's how that works. Now, the key thing is the not. We want to know which one of these is wrong. So starting over here first, we have, I just did this one actually. We put a 1 in and we got 5.5. Well, that one is correct. The first one right here is correct. However, don't assume just because the first one is right that they're all going to be right. Like, for example, if I get myself out of the way here, you'll see that J also has a 1 of 5.5. Two things can't be correct, so you got to see which one's not right. So then you put a 2 in. So 2, and the same thing, plus 4.5 is 6.5. Awesome. 3 plus 4.5 is 7.5. Awesome. 5 plus the 4.5 gives you 9.5. So F, all 4 of them are correct. We want to know which one's not correct. So F is not our answer. One of these 4 has it wrong. And by now, you're probably already seeing it. Let's go down here to, I'm going to skip ahead to G. G, if I plug in 4 plus 4.5 is not 18. That's the wrong one. 5 plus 4.5 is not 22.5. These are not following the rule. Therefore, this table does not represent this rule. Now, on your cases, you need to check all your answer choices to make sure that's the only one that doesn't fit. But in this case, I'll tell you G is the correct answer. If you have any questions, let us know. But other than that, thank you for watching it. See you tomorrow.